section, we're going to first look at greatest common factor, how to pull out a greatest common factor out of any polynomial, if there is one. Then we're going to move on to specifically factoring trinomials. A trinomial is a polynomial that has 3 terms. And then we're going to look at the difference of squares. The formula for a difference of squares, and we'll go into detail of where this comes from later, but it starts off as a squared minus b squared. So we literally have a difference of 2 squares, 2 quantities being squared. That's always going to factor to the first quantity being squared minus the second quantity times the first quantity plus the second quantity. And it can be written in the opposite order, so you could have a plus b times a minus b as well. And we'll go over that when we get to a difference of squares example. Our first example here is for us to factor x to the 4th minus 5x cubed plus 7x squared. Like I said, the first thing you always want to try to do when you're factoring a polynomial is to look for a greatest common factor. Well, I first look at the coefficients. The leading coefficient here is a 1. Then I have a coefficient of -5 and a 7. Well, they have nothing in common, but I do notice that they all have x's. In fact, they all have an x squared term. That is my greatest common factor. So I go ahead and factor that out, and then in parentheses I write what I'm left with. When I pull x squared out of x to the 4th, I'm left with x squared. Then I'm left with a minus 5x and plus 7. Our next step would be to look at this remaining trinomial and see if we could factor it further, but I'm going to go ahead and tell you that that cannot be factored. We actually haven't factored those yet. Those will be in the next few examples. So we can go ahead and stop, and I've gone and I've factored x squared times the quantity x squared minus 5x plus 7, and that is my solution. Example 2 asked us to factor x squared minus 5x minus 14. Again, the first thing you always want to look for is a greatest common factor. X squared, 5x, and 14 don't have anything in common. So now we're going to move on to other techniques of factoring trinomials. Again, this is a trinomial because we have 3 separate terms, x squared, minus 5x, and minus 14. So on the side, I'm going to kind of give you some steps of how to factor trinomials, and this is going to work for every trinomial that you're given. First, you need to know that trinomials are of a certain form. That form is ax squared plus bx plus c. Okay, the a, the b, and the c are the coefficients. Now, knowing that, the first step for factoring a trinomial is to multiply a and c, so a times c. For our example, my a is just simply 1. So I'm going to multiply 1 times my c is -14. That gives me -14. Next thing I'm going to do is I'm going to go ahead and I'm going to try to find factors of my -14 that add up to my middle term, which is -5. So I'm going to find factors of my a times c that add up to b. So again, for my example, I need factors of -14 that are going to add up to -5. Well, what times what will give me -14? If you're not sure, you can kind of on the side list them out. You say, okay, factors of 14, ignoring the negative, are 1 and 14, and 2 and 7. Well, which of those are going to give us 5? The only way we're going to get 5 out of this is if we use the 2 and the 7. So I'm going to go ahead and put my 2 and my 7 here. But I know that it's a -14. Oh, I lost my cursor. Give me just a sec. There we go. So I know that this right here is going to be a -7. 2 times -7 is going to give me the -14 I need, and 2 plus -7 is going to give me the -5 I'm looking for. What that allows allows me to do is take this trinomial and rewrite it with 4 terms. And here's how you rewrite it. It becomes x squared. I'm going to take those 2 terms, so plus 2x minus 7x minus 14. So I took that negative 5x and I broke it into 2 pieces. It's still equal to negative 5x if we simplified, but now I have 2 pieces. Now, what that allows us to do is to factor a greatest common factor out. And let me show you how that's done. I, for ease, make a grid. In my grid, I make it into 4 boxes. In this upper left-hand corner goes my x squared term, which in this case is 1x squared. In my lower right-hand corner, I'm going to put my c term. And then in these 2 boxes, you're going to put the 2 pieces you broke your middle term up into. So I'm going to put 2x and negative 7x. It doesn't matter which box you put it into. Next, you're going to pull out a greatest common factor out of each column and each row. So I'm going to start with this first column here, x squared and negative 7x. The greatest common factor here is an x. The next column, 2x and negative 14. The greatest common factor is a 2. Now looking at the rows, x squared and 2x, my greatest common factor is an x. And then here, negative 7x and negative 14, I have to remember that if I have 2 negatives, I have got to factor out a negative. Okay? So negative 7x and negative 14, the greatest common factor is actually a negative 7. What that leaves me with is my 2 factors of this trinomial. So x squared minus 5x minus 14, my original trinomial, is now going to factor to x plus 2 times the quantity x minus 7. Those are my factors. Example 3, factor 5x squared minus 10x minus 40. If you remember, I said the first thing you always want to look for is a greatest common factor. So when I look at these 3 terms, I see that they all have a 5 in common. So I'm going to go ahead and factor out the greatest common factor, which in this case is a 5. That leaves me with x squared minus 2x minus 8. Like I said before, sometimes you will factor out a greatest common factor, and then you still have to factor a little bit further. So I'm looking at this trinomial, x squared minus 2x minus 8, and I want to see if I can factor it. Remember, the first step is to multiply a times c. So in this case, my a is a 1 again. So 1 times a negative 8 gives me negative 8. I need to look for factors of this negative 8 that add up to my b. In this case, my b is a negative 2, so I want this to equal negative 2. What times what will give me negative 8 and also add up to negative 2? Well, that's a negative 4 and a positive 2. So again, I'm going to rewrite this. My greatest common factor that I pulled out originally just stays hanging out in front. Then I have x squared minus 4x plus 2x minus 8. Remember, I took this negative 2x term and I split it up into 2 separate pieces. It's still equivalent. What do I do next? I'm going to take what's in parentheses and I'm going to make that into my grid. So I'm going to do my grid over here this time. Remember, my x squared term goes in this corner, my constant goes in this corner, and then my other 2 pieces, it doesn't matter which block they go into. And then I'm going to factor out the GCF in each row and each column. So this column, the greatest common factor is an x. This column, the greatest common factor is, remember, a negative 4 because they're both negative. In this row, the greatest common factor is an x. In this row, the greatest common factor is a 2. So that leaves me with this 5. And then I have x minus 4 and the quantity x plus 2. I have successfully factored 5x squared minus 10x minus 40. Again, I used greatest common factor and then I had to go ahead and break down that next trinomial. Example 4, factor 2x squared minus 7x minus 30. Going back, again, the first thing you always want to check for is the greatest common factor. As you can see, 2, 7, and 30 don't have anything in common, and they don't all have x's. So we can continue on. Then we're going to move on to the AC method. So what I need to do is I need to take my A times my C. So in this example, my A is 2, so I'm going to have A times C. 2 times negative 30, which gives me negative 60. What are factors of negative 60 that are going to add up to negative 7? Well, if you need to pause it, please do. It's going to give me, let me get my cursor back, my apologies. That gives me negative 12 and positive 5. So I can rewrite this trinomial as 2x squared minus 12x plus 5x minus 30. Now, once I have it in 4 pieces, I can set up my grid. Remember, my x squared term goes up here, my constant goes down here, and then my middle terms, negative 12x and 5x, go right here. So again, we factor the greatest common factor out of each column and each row. So here, the greatest common factor is 2x. The greatest common factor here is 5. Greatest common factor here is x. And again, 2 negatives, we have to remember to factor out a negative. That leaves me with negative 6. So this factors to 2x plus 5 times the quantity x minus 6. Example 5. Factor 24x cubed plus 2x squared minus 12x. Again, the first thing you want to look for is the greatest common factor. We see 24, 2, and 12 are all divisible by 2, so I know I'm going to factor out a 2. And I also see that they all have an x in common, so I'm going to factor out 2x. That leaves me with 12x squared plus x minus 6. From here, I have a trinomial here, so I'm going to see if I can factor it. First thing I'm going to do is I'm going to multiply my A times my C. So 12 times negative 6. 12 times negative 6 is equal to negative 72. I need factors of negative 72 that are going to add up to a 1 because my coefficient right here in front of x is a 1, even though I don't have it written. All right, factors of negative 72 that add up to 1. Well, I know 9 times 8 is 72. Which of those needs to be negative? Well, in order to get a positive 1, I need the 8 to be negative. So I'm going to rewrite this as 2x times 12x squared plus 9x minus 8x minus 6. Then I'm going to set up my grid. My x squared term goes here, 12x squared. Then my constant term goes here, my other 2 terms, and these 2 boxes. All right, so here we go. 12x squared minus 8x, what do they have in common? 4x. 9x minus 6, they're both divisible by 3. The greatest common factor here is 3x. The greatest common factor in this row right here, again, we have 2 negatives, so I'm going to factor out a negative 2. That leaves me with 3x minus 2 times 4x plus 3. But remember, you have this 2x still hanging out in front. Example 6. Factor 9x squared minus 6x plus 1. Again, the first thing you always want to do is look for a greatest common factor. We can see that there's not one in this problem, so I move on to my A times C method. So I start off with A times C. My A is 9 MIC is 1. 9 times 1 gives me 9. I need factors of 9 that add up to a negative 6. That's going to give me negative 3 and negative 3. So I rewrite this as 9x squared minus 3x minus another 3x plus 1. Now I can go down and make my grid. I have 9x squared and my 1 here, and I have negative 3x and negative 3x. Now, this one's a little tricky. Again, we're factoring out a greatest common factor in each row and each column, but we need to be careful. So let's go with our first column. 9x squared and 3x, what do they have in common? A 3x. Now, here's where it gets tricky. We have a negative here, but we have a positive here. When you have a minus in the middle, but you have a positive C term, you're going to have to factor out a negative. So this is going to be, what do negative 3x and 1 have in common? They have a negative 1 in common. I know it looks weird, but that's what you have to do. Now here, 9x squared minus 3x. What do they have in common? 3x. Same thing here. What do negative 3x and 1 have in common? A negative 1. That leaves me with 3x minus 1 times another 3x minus 1. All right, we got the same two factors. Well, an easier way to write that would be 3x minus 1 squared. Okay, either way is correct, but example 7, factor x squared minus 121. Now, you see there are only two terms, so we're no longer dealing with a trinomial, but you still look for a greatest common factor first. You see that x squared and 121 don't have anything in common. So now we need to look at our difference of squares. So I'm going to refresh your memory. A squared minus b squared. Let's go ahead and write this as something squared minus something else squared. Well, x squared is just x being squared. What is 121? How do we break that down? Well, 121 is 11 being squared. So this is my A right here, and this is my B. Okay? So A in this term is x, B is the 11. So to factor this, my two factors are simply x minus 11 and x plus 11. Example 8, factor 50x squared minus 98. Again, we see there's just two terms, so it kind of keys us in. We're probably going to use difference of squares. But the first thing you always look for is the greatest common factor. Well, 50 and 98, what are they both divisible by? A 2. So I'm going to go ahead and factor out a 2 to start with. Let me get my cursor back. Here we go. And that leaves me with 25x squared minus 98 divided by 2 is 49. So now I have to look at this quantity here in parentheses and see if I can factor that further. Well, good candidate for a difference of squares because we still have two terms. So the question is, can I write 25x squared as something being squared? And can I write the 49 as something being squared? Well, the 49 is easy. 7 squared gives us 49. 25x squared, well, that breaks down to 5x being squared. 5 squared gives me the 25. X squared gives me the x squared. So I'm going to go ahead and put brackets around that since I went ahead and used parentheses. And this 2 gets carried down. It's still out there. It's the greatest common factor of my original polynomial. So now I have 2. And remember, I know how to factor a difference of squares. I take the first quantity being squared minus the second quantity times the first plus the second. Okay? This can be written simply 2 times 5x minus 7 times 5x plus 7. You don't have to have the brackets.